This video will present solutions to the VCE 2019 Mathematical Methods Written Examination 2, Section B, Question 5. Question 5, Part A. The tangent to the graph of f at the point where x equals a can be found using the ClassPad's tan line command. I'm going to write my result in y equals mx plus c form. Part B. The x-coordinate of q, the y-intercept of the tangent, can be found by setting the tangent's equation equal to 0. This equation can be solved with some relatively simple rearrangement. Part C. The x-coordinate of P, where the tangent meets the curve again, can be found by equating the tangent and the function and solving. The ClassPad returns two solutions. The solution x equals a corresponds to the point of tangent C, and so the x-coordinate of point P is x equals minus 2a. Part D. There are many ways to express A, the area shaded, in terms of a. One way is to find the area between the tangent and the function from x equals minus 2a to x equals 1. And then add to that the area of the triangle from x equals 1 to the point Q. This can be calculated as the definite integral from minus 2a to 1 of the tangent minus the function plus the area of the triangle, calculated using a half times height times base, with the tangent's y value at x equals 1 as the height and the x-coordinate of q minus 1 as the base. First, I'm going to compute the definite integral between the tangent and the curve. To this answer, I'm going to add the triangle. Tapping Simplify gives us an expression for the area. Part E. The value of a for which this area is minimized can be found by solving the derivative of this equation equals to 0. I will use the calculation derivative command of my ClassPad to differentiate the expression with respect to a, and then solve this answer equal to 0. This gives the result a equals 1 over 10 to the power of a third, as a is between 0 and 1. This result could also have been obtained using the fmin command, but as this question is worth 2 marks, some evidence of method was required. Part F. In Part F, the function is reflected through the line y equals x to become f inverse. As area is preserved by this reflection, the minimum at a, f of a, as found in Part E, will correspond to a reflected point f of a, a on the inverse function. Therefore B, the x-coordinate corresponding to minimum area, will be the function value f of a, using the previously found value for a. Part G. To find the angle between two tangents, a good place to start is to find their gradients, and then find the angle that they make with the x-axis using the relationship m equals tan theta. Firstly, the tangent to the graph of the function f at the point where x equals 1 can be found using the ClassPad's tan line command. The tangent at the point 0, 1 seems to be horizontal, a result that can be quickly confirmed by modifying the previous command. As the tangent at the point 0, 1 is horizontal, the tangent at the point f inverse at 1, 0 will be vertical. As such, the acute angle between the tangents will be pi over 2, a right angle, minus the arctan of -3.